test before touch. I'll repeat this all day because it's important. All conductors got to be treated energized until all steps in lockout tagout are completed. And how do we verify that the circuit is de-energized? It's called the live dead live test. The live dead live test has 3 steps. Step 1 and 3 are the same. Test your meter. You got to test your meter. So if we're going to go out and turn off, let's take that plastics plant we just talked about. If they're going to go out and turn off that injection molding machine number 16, then they turn off open the disconnect that controls, is protecting this machine. Then they don the proper PPE that machine requires. That would be for arc flash and for shock. Then they go test their meter on a live circuit, make sure it's working. Then they go to the circuit they've turned off and they test for absence of voltage. And when they test for absence of voltage, you've got to measure phase to phase. And we're talking about 3 phase here. So L1 to L2, L2 to L3, and L1 to L3. And you have to do all of them. Don't let anyone say, well, you don't really have to do all of them. You just check 2, then the others 2 going to be off too. Nope, that's not true. Because the fork truck driver on 3rd shift may have rewired your circuit for you. So you're going to check all of them. You do L1, L2, L2, L3, and L1 to L3. Okay? Then we got to measure phase to ground. And again, we got to do all of them. Phase 1, 2, and 3 to ground. Some people might say, well, hell, if you just check one of them to ground, all of them going to be down. Well, that's not true. That's not true. Throw something heavy at that person and then check all 3 to ground. Okay? Because, again, 3rd shift fork truck driver may have rewired your circuit. Also, there is a 3-phase distribution system called corner grounded delta, B-phase ground, that the center leg is always grounded. It doesn't have a neutral, but the ground reference is the center phase. So L2 is always grounded. So if that's the only one you check, even if it's turned on, it would show 0. So check all 3 to ground. And if you got 0 on all these tests, then retest your meter on a live circuit to make sure the meter's still working. The idea there is if it worked before and it worked after, probably was worked during, right? So that's how we test before touch. And you can't skip any of these steps. You've got to do all of those. And it's important that we don't take any shortcuts here. And don't let anyone tell you anything different than what I just said. Okay? And probably you shouldn't throw something heavy at someone at work. But, do what you got to do. I like Fluke. I'm a big fan of Fluke because, well, for a lot of reasons. But one is they make products that make our life a little bit easier when it comes to electrical safety. Fluke has proving units. And a proving unit is an easy way for you to test your meter. If you see that picture with the person in the orange hat, they just put this proving unit right next to their meter, and it's battery operated. And those 2 points down here at the bottom are 2 finger safe test points and there's a switch on there. You can choose your voltage and you can test your meter with this device. It's battery operated, so there's no big arc flash problem with it. And it's finger safe, so it's still going to be wearing your gloves, but you got to check your meter with that. It just makes checking your meter with a live circuit much easier. Then you check your circuit, then you go right back and check that again. Now, if you've got a capacitive coupled meter like a T5 or a T6 that uses the fork type where you just put the wire between the forks, they've got a special unit for that one where you can test your meter with this. One thing I like about Fluke is their website has lots of information about their equipment and how to use it. Lots of videos. I've been in the training business for over 30 years. And 2 words I hate to see used together is free training. But Having said that, Fluke's website has a lot of good free training. They do. And I wouldn't be doing my job if I didn't tell you to go look at it. They've got some information. They've got one PDF you can download called the ABCs of Digital Multimeters. Everybody that uses a digital multimeter should read this. ABCs of Digital Multimeters. They've got another one on capacitive coupled meters. And that's like a T6 or a non-contact voltage detector. And everyone should read that too. But they've got a lot of good videos and training and stuff. So highly recommend. I've got a good question here. Let me go back and see that. Thank you, Gary. If I don't have a proving unit, can I test the meter on a 120 volt outlet? If I'm going to be working on a 480 volt piece of equipment, you can. You can test your meter on 120 volts, even though you're going to be using it at 480. When this first came into 70E, this is like 3 code cycles ago, the regulation was you had to test it on the same voltage you're going to be using it on. And that was only in there for 3 years and they took it out. So that's no longer in there. So to answer your question, you do not have to test your meter on 480. You can test it on 120. The proving units have another good use. If I used to work at a plastics plant, and we had these huge silos, 75 feet tall or something. And the days of me climbing a 75-foot silo are gone. I ain't doing that. But if and of course we weren't following 70E back in the 80s when this occurred. So, but think about if you were up on a silo and you had to work on something, would you had to have climbed down, test your meter, climb back up, done it, and climb back down to test your meter? And maybe it's not a 75-foot silo. Maybe it's just a machine that you got to climb up a ladder, whatever. So the testing units, very inexpensive, and they're very handy. I like anything that makes 70E a little bit easier. Gary, great question. Student of the day so far. So thank you very much. And no, you don't have to test your meter on 480 if you're going to be verifying 480.